Alright guys, I'm about to start this. About 6 minutes. Let me know if you guys can hear me. Make sure everything's working. And if you guys can't stick around, it will be uploaded, so don't worry. Alright, about 3 minutes, guys, I'm gonna start. Go ahead and in the description, if you want to follow along and do some coding, there's going to be a project down there. I'll try to go slow enough that you can follow along. And if you can't follow along, don't worry, it'll be uploaded after I'm finished. Again, if you just joined, you can go ahead and download the starter project below. It's GameMaker Studio 2. If you're using an older version, you could still follow along. You might have to wait. I don't know if I'm going to be able to give you enough time to set up the project, but the code will basically be exactly the same if you're using an older GameMaker version. Alrighty. Alrighty, so let's go ahead and get started. If you're just now joining me, go ahead and download the starter project in the description. GameMaker Studio 2. If you're using an older version, then just try to follow along with the video. You might have to watch it after it's uploaded to really get up to speed to be able to set the project up. So, yeah. Go ahead and let's go ahead and get started. So today we're going to be doing a multiplayer project. Let me go ahead and put off the music. Come on. Put me to sleep here. Let's go. Alrighty. Welcome guys. So yeah, hopefully you guys are following along here and you don't have to do the code live right now. You can just watch and follow along if that's what you want to do. It's totally fine. So Let me go ahead and switch the video over to my face or something. Okay. Hey, what's up, guys? Okay, so first let me give you a little rundown of what's going on. So I'm going to be doing a multiplayer series showing you how to code online games in GameMaker Studio 2. It's a pretty complicated subject. If you don't understand buffers and data structures, go watch my previous live streams. You can still watch this, then go watch my previous live streams. It might connect the dots for you. But basically, yeah, I'm going to be doing a multiplayer stream. I'm going to be doing live streams, I think, for now, for probably the next month, instead of doing videos, because I just don't have the time to edit, render, and upload the videos right now. So the live stream works a lot better for me. Let me make sure my mic... Yeah, it's using the correct mic. Okay. So, yeah, it's quite a complicated subject. We're going to be going into a lot more detail than maybe other tutorials do. I'm not going to be giving you the perfect architecture, basically, for your game. Every game is a bit different when it comes to multiplayer. So, yeah, you're going to have to kind of do a little bit of critical thinking on your own, but I'm going to give you the tools to where you know how to optimize it the way you need it. I'm going to give you that knowledge. So that's the goal, not necessarily to give you all the answers to all the problems, but I'm going to be showing you all the techniques basically that are used in modern day real-time games. So first-person shooters like Battlegrounds or Call of Duty, I'm going to be showing you the techniques they use to overcome these issues. And as far as the architecture and putting everything together, there's 100 ways to do it, and there's a lot of ways to make it easier on yourself. So after this, you'll be able to also use like libraries in GameMaker like GMNet, and you're going to understand what it's doing behind the surface. So when you're actually using it, you'll be able to understand how to actually implement it. And GMNet's a pretty cool little library for GameMaker that makes it pretty easy to develop multiplayer games in. And it's not perfect. There's a lot of things that need to be optimized with it as well, and you're going to kind of realize how to do this stuff. But anyway, I'm going to give you the knowledge that you'll be able to kind of understand what's going on behind the scenes. You can make your own if you want, or you don't even need to make a library. You just implement it straight into your game. So we're going to kind of go over that. So the stuff we're going to be going over is basically basic packet sending, how to create messages, message types for different packets, how to load and unload the packets, and then we're going to be going over, and we're going to be using basically only UDP, and we're going to be creating TCP-like behavior with UDP, which is what many games use. And then we're also going to be doing stuff like client-side prediction, server authorization, or authoritative, basically. The server is going to be having the final say of where every client is positioned and the moves they're allowed to make. And we're going to be going over, yeah, a lot of those advanced topics. Quad trees, which are used in things like massive multiplayer games to basically send data to only users that need the data. So there's not 1,000 people in one world sending data to each other. It's only certain users sending data to each other that are in a certain proximity. We're going to be going over that, and there's really quite a few. Server reconciliation is another one. So when your server and your clients disagree on where they should be, basically where the client should be located, how do they reconcile and how do they meet up to an agreement? We're going to be going over that. And you're going to see these problems, but yeah, let's go ahead and kind of jump into it, because I'm getting ahead and you probably know nothing about what I'm talking about. So let me go ahead and get this stuff closed out. And kind of creeping myself out because I'm seeing my video over here. Let me pause this. Okay. All right. I keep thinking someone's behind me or something. All right. Okay, so we're here on the desktop, and if you oops, is this the right one? Hopefully you downloaded the project, and if not, it's fine. Like I said, you can just watch and try to understand everything that's going on. So if you have it open, let's go ahead and open the project. It's in the description below. And you'll see that I've kind of set this up. So in my original example project that I've done, I've actually had two different projects. So I've had a server and a client that were totally separate Game Maker Studio projects. But for simplicity of showing you guys how to do it and doing tutorials on one screen, I have combined the projects for this series. So the thing you need to understand about this is the server and the client are completely separate applications. They have completely separate logic. Now, they will have some shared things, like they could share sprites and they can share certain code that we're going to be putting, such as any constants that need to be used in both the server and the client. But as far as logic goes, they're completely separate, so they do not communicate through direct code inside this project. So any server object cannot directly communicate with the client object via code. It will all be done via network and using packets, okay? So I need you to kind of understand that before we start doing this so you're not confused. And as I said, just think of it as two completely separate projects, okay? Imagine having two Game Maker projects, okay? That's how it's going to work. So you'll see I have shared folders. So this is going to be shared, basically sprites, like in the sprites that are shared between both the client and the server. And I've shared client server objects and basically any resource. So you can see my buttons I have shared. And if we go to the main menu, obviously before you even start the server, whether you're doing a server or a client, they're both going to go to a main menu, and you're going to kind of click which one you want to go to, okay? And that's where it branches off. So it'll either go to the server playtest room or the client playtest room. And yeah, that's it. And I prefix the servers with SV, and I prefix the clients with CL. So yeah, that's how we know what it is, and we're going to do that for all the resources. And I've decided not to use snake case, so you don't see sh_client_button, because yeah, I don't like using that. When you start getting descriptive names, it gets really long in the resource tree, and it's kind of irritating to type out. So I use camel case, which is the first letter of every word, capital. Unless I do scripts, then usually I use first letter, lowercase, and then every beginning letter after that, uppercase, basically. Okay. And then I have the prefix. That's the only thing that I separate with the dash. That's just how I've decided to do it. That's just how I program. So let's go ahead and get started. What's the first thing we're going to do? So the first thing we're actually going to do is implement a kind of messaging system, not a messaging system, I guess it would be a messaging system. Basically, somewhere on our server that it logs messages at the top for us, so we can it's easier to debug, and it's also going to lead into our chat system. It's going to be kind of cool. It's going to show you the newest message at the bottom, and then any message that gets added, it's going to kind of show all the old messages up to as many as we want. So if we only want 6 messages to show, we can specify that. So let's go ahead and get started with that. So I'm going to, and again, this has nothing to do with networking. This is just a simple message system that's going to allow us to debug pretty easy. So I'm going to go to my server, object, SV server, yep. And I'm going to create it. And the first thing we need to do is initialize this messaging system. So for the description, I'm just going to put init everything, init server basically, okay? And at the initialization of the server, we want to create a messaging list, basically. So this is kind of like an array. If you don't know about lists, be sure after this stream is over, or before if you want, go watch my data structures stream. So a list is basically an array, okay? Or it's a list of items that we can keep, and the list data structure in GameMaker has some stuff like sorting and adding and inserting at specific positions in the list and things like that. So how do we create a list? It's pretty easy. We need to save it in a variable first of all, but you just basically do dslist create. Pretty easy. Come on, my cord's in my way. All right. And then you need to save this list to a variable. That's it. So we're going to call this message list, and that's it. There you go. You have a new list created, and it's called message list. That's how we reference it. And let's say we wanted to add a new message to our list. We simply do message, or we have to add it to our list. So we do dslist add. Okay, and you'll see it takes two parameters. It takes a message list. Basically, it takes a reference to a list you've already created, and then it takes the value you want to add to it. So let's add a string. Let's add a message. Server initialized. There you go. Pretty easy. And as I said before, we want to actually limit how many messages can be in this list. So let's up here, let's create a constant, and I specified constants with all caps. Let's say max, messages equals, let's say 6. That's fine. And then under this, we simply do if dslist size, which gets how many elements are in our list. So if we've added how many elements we've added, we say if dslist size, and we have to give it a list to check the size of. We give it message list. If that size is greater than max messages, and we actually have to do -1 because we only want 6 messages, and lists and basically all data structures start at index 0. So if you count 0, then the maximum amount of messages we'd want would be up to 5 because 0 counts as a message, okay? So we're actually going to do max messages -1 to keep it consistent. So now we can only have 6 messages showing. And let me get my parentheses correct. Yeah, I have it correct there. Then we want to erase our oldest message, which is going to be basically at the first index, okay? So let's do dslist. Let me think about this real quick. Okay, yeah. When you use dslist add, it adds it onto the end. So we're going to just remove the first message, basically, okay? I'm trying to think if this is the optimal way to do it. Yeah, it's pretty good. We're going to do dslist delete, which is going to allow us to delete a certain element in our list. And we're going to delete the one at the first position, which is going to be 0. Pretty easy. There you go. Now we have our basic list, and we're going to actually move this to a script in a moment, but yeah, let's go ahead and do that. So we're going to actually go into the server scripts. We're going to say create script, and let's create a script, and I'm going to prefix it with SV, and we're going to say add log message, okay? That's going to be my script name, and this is going to take in an argument, and I'm going to use var, and I'm going to name this variable message, and it's going to be set to argument 0. So I'll explain this in a moment, but basically var, I use this because when this script is finished executing, whatever this is going to be cleared from memory. So this reference is not going to exist anymore. So yeah, it kind of cleans up memory and cleans up variable names for us. Another thing I like to do in scripts is put an underscore before my variable name. This is because when you call a script, it actually, you can kind of think of this code copy and pasting into wherever you call the script from, okay? And if you already have a variable named message, it's actually going to mess some stuff up, which is quite annoying, and I run into a lot. So anytime I use variables in scripts, I use an underscore in front, and this kind of lets me know, hey, this is going to be used only in the, basically the script. It's only going to be used in this scope. Okay, so now we've assigned our message, and I'm going to oops, that was wrong. I'm going to copy and paste that code from our server. Actually, cut and paste. I'm going to cut all of this. We're going to leave the list create and the max messages here. And I'm going to paste this into our log message. And instead of this server initialized string, we're going to replace this with underscore message. So basically, that's what argument 0 is going to be, is the message we want to add to our list. And the script is complete. I just copy and pasted what we had in the server create event into here. I'll give you a second if you're following along. 1, 2, 3. All right. Yeah, so that's it. And then instead of all that code, we're now just going to call in our create event of our, ooh, why is this called object 8? Did I create a new object? Oh man, I am way bad. Okay, so I accidentally created a new object here. If you're here with me, I'm going to cut this out. I'm going to delete this object. This all goes into the server. Sorry about that. So let me add a create event to our server, paste all this in. Okay. So we're going to call our script that we just created. We're going to say add log message. And in parentheses, we're going to put our message we want to add, and that's going to be server initialized. There you go. This is going to do the exact same thing that we just had. And if you're an expert GM programmer, then you already know this. And it's boring, but we're going to get to the cool stuff in a moment. All right, so now let's draw our messages to basically our screen. So let's add a new event and call it draw GUI. Trace log. Trace log. Someone said trace log. What do you mean? Is that what I should have named it? Okay, so draw GUI, and we're gonna say draw stuff, because we're gonna draw a lot of stuff, I'm sure. We'll specify this later. And let's say, let's run through all of the messages in our list and draw them to the screen. So how do we run through our entire list? Well, we simply do for. Hopefully we get for each loops soon. We're gonna use for, and we're gonna say var. Remember, anything that we specify with var will get cleared from memory after the script is complete. So we're gonna say var I, which is gonna be basically iteration, equals 0. We're actually gonna change this in a moment, but this is how I'm setting it up for now. And we're gonna say I, as long as I is less than ds list size. And what's the size of our list? Or what what list are we getting the size of? We're getting the size of our message list. I'm just going to copy and paste that in the parentheses. And then we're going to say I++. Easy. And now we're going to draw text. Draw some text, and let's grab the value that's inside of this index inside of our message list. So where are we going to draw it at? We're going to draw it at 10 to the left, or to the right. So you go to the left side of the screen, move over 10 pixels. And what Y value? The Y value is actually going to change depending on what iteration we're on, because we want the text to be drawn on top of one another from from newest to oldest at the top. So we're actually going to say, we're going to start, basically our newest message is going to be at about 150 pixels down, and we're going to have to subtract from it for each iteration of I. We're going to have to go up, 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 up. Yep, so in parentheses, we're going to subtract I times the spacing, basically, you want between text, and I'm going to put 20 pixels. You could actually do some better math, getting the font size and whatnot for that, but we're not going to worry about that for now. And then what are we going to print out? We're going to print out the contents of basically this element in our list. And how do we get that? We use message list, and we're going to use what we call an accessor. So in normal arrays, you can use these brackets, but since it's a list, we have to specify that it is a list by this weird thing. This is kind of a weird thing you have to put in these brackets. So this tells GameMaker, hey, we know this isn't an array, a normal array, it's actually a list, and get us the element at position I in our list, okay? And as I said, index 0 in our list is actually going to be the oldest message. So we're actually going to have to kind of reverse this in a moment, but let's kind of see what we mean by that. So I'm going to go to my create event, and let's add 2 more messages. So we're going to say server initialized 1, server initialized 2, and we can actually, I believe, run this now. So I'm going to give you about 3 seconds to get this down. So 1, 2, 3. I'm going to hit play. And I'm going to hit server, because this is the server that we're actually doing this code in. And you'll see server initialized 1, server initialized 2. So this is actually giving me the result I wanted, I believe. So the newest element, no, we want the newest element on bottom, okay? So right now we have the oldest element on bottom, because that was the first one added in the list. So how do we get the newest element on bottom? Well, we start in reverse. instead of starting at index 0, we start at index DSList size. And instead of increasing, we're going to be decreasing because we're starting at, basically, if you had 6 messages, we're starting at 6, which would be the newest message. So we're going to say as long as as long as I is greater than 0, we're going to decrease. So we kind of just reverse this. Now if I hit play and do this, we might actually get an error. Let me make sure I'm doing this right. Yeah, I think undefined, yeah. So we actually need to do DSList size -1 because this is, remember, this is returning the actual size of our list, and since the list is indexed at 0, that's when it starts, we actually need to subtract 1 from it in this case. Let's see what happens now. We should get that oldest message first. Okay, and it's not going down enough, so we actually need to do I is greater than -1. I know this looks kind of weird, but we just had to kind of reverse the iteration. And I don't do this a lot, so that's why it took me a couple tries. But yeah, the code's there. It's going to iterate through our list in reverse. There's probably a better way to do this, I don't know. But yeah, wait, server initialize 2. Is this still not correct? I'm so confused. Okay, yeah. No. This is not correct. I equals... Oh. What did I do wrong? Come on, give me a break here. So we're starting at, let's say, 3, or starting at 2. And we're printing out 2. Oh. Let's actually do plus, and let's start at 10. Okay? I think this might have actually been a better way to do it in the beginning anyway. Let me see if this works before I tell you guys wrong. 1, 2, 3, server initialize 2. This is not giving me the result I want. I'm not going to spend too much time on this. It's not right. just know it's not right. It's not what I expected. Okay, so we're going to go ahead and move on to the networking stuff, though. You could spend time on this and figure it out, but I'll just let you know it's not what we're expecting. So we want to start down here and then move up. I'm just missing something simple, I'm sure. But I'm going to take out my first 2 messages. We're just going to have server initialized as our message. And this will work just fine for now. But it's just going to start the message at the top. And then that message is going to actually get pushed down, which is totally fine. But if you had like a message box, it wouldn't give you kind of the effect you wanted. So let's go ahead and move on. Now that we have basic message system, we can easily add logs to be shown on our server. So let's get into networking stuff. How do we actually send a packet? So when our client starts up, let's go ahead and start our game. I'm going to hit play. Obviously, we have to have a server set up first for our client to connect to. And we're going to set that up here. So when you click server, it's going to initialize everything we need. And then when we click client, it's going to connect to our server. Okay. And again, these are 2 separate applications. Think of it that way. So let's talk a little bit about some stuff we need to talk about. So how do we initialize this stuff and get it going? The first thing we need to do is establish a connection, okay? And how we do that, how you do that using TCP, let me back up. TCP and UDP, 2 different protocols. Most tutorials for GameMaker show you kind of how to use TCP, and that's because using TCP is safe, okay? But it is not fast, and it's not good for real-time games. TCP is a type of protocol that you use to basically send a packet. So if you sent a connection packet, you want that packet, or a connection request, let's say a request, because I haven't explained packets yet. Let's say you send a request to a server to connect, okay? Using TCP, TCP would ensure that that request was received by the server, such as it would send the request, and if for some reason through the internet networking it did not make it to the server, it would send it again until it got a reply from the server saying, hey, I got your packet, or I got your message, and yeah, you can connect, okay? So it actually kind of waits for that reply from the server, okay? And As you can imagine, this takes some time. And this time is not good for things such as position updates. So let's say you move your character and you want your position to update, and you need to send that update to the server. Well, now you have to wait for the server to reply saying, hey, I got your position update. And another thing about TCP is it makes sure it gets packets in order. So let's say you're continuously sending position updates, and for some reason it misses the first position update you send, and the second one gets there. Well, it's waiting on that first one before it processes that second one, okay? And obviously that first one you sent doesn't even matter anymore because you have a newer position that you're trying to update. But that first one got lost, so it's like, hey, send that back to me, basically. So your client's gonna wait and didn't get a reply that the server got its old position update, so it's gonna send it again, wait for a reply, and then finally the server says, hey, I got your first position update. And then now it can process your second position update as well. I know this sounds kind of confusing, but basically this takes a lot of time because the server is ensuring that the packets, or sorry, the person that sends the data is ensuring that those packets are getting sent and they're getting received, and they're getting received in order. And the order doesn't always matter, and even getting received doesn't always matter. So using UDP is more like you send some data, you don't care if it gets received, you're not waiting for a reply, you're just gonna keep sending data to the server, okay? Now, this is really good for updating positions frequently. So your character's moving along down a road, and you need to continuously update the server on maybe your positions. And if one of the packets gets lost, it's not such a big deal because maybe it gets the next packet, maybe it gets the next stream of data, your next position update. That old position doesn't matter anymore. So in that way, UDP is kind of better because you don't have to wait for that reply before it can process your stuff. You're just sending data, you don't care what it does with it. So in that sense, UDP does not have a sense of connection. TCP does. TCP requires basically a connection, and yeah, it handles all that stuff for you. UDP, you don't even need to make a connection in GameMaker. And I'm going to show you what I mean by that here in a moment. But yeah, send data. Don't care if it gets received. And another thing to note is, let's say you do want to make sure a message gets received. You can actually implement TCP behavior using UDP. There's ways to implement that. So we can actually send a piece of data, and we could say on the server side, say, when we receive this piece of data from a client, we need to make sure we send a message back telling the client that we got it. So things such as chat messages, maybe you want to make sure those get received, and they need to get received in order because it wouldn't make sense for messages to be jumbled up or something, okay? So there are instances and times where we need to kind of use TCP-like behavior. But as I said, we're going to be using UDP, so let's kind of figure out how to send a message. Let's get into it. Alrighty, oops, that was the wrong overlay. Alrighty, so as I said, it's going to start from the client. And as I said on another note, that there's not a sense of connection right now. We're just going to try to send a message and see if we can receive it on our server. So let's start with our client. Let's close our server stuff down, our folder, so we don't get confused. And let's open up our client. And I'll explain these other objects later, but don't worry about them right now. And let's open up our connection handler. So this is actually going to handle sending and receiving data to a server, okay? And these other objects are basically just going to be used like normal objects would be used. So let's go ahead and open up the connection handler. I'm going to hit our create event, and let's fill out our description. I'm going to say init connection, which again, we're not going to establish a connection right now. We're just going to send a piece of data saying, hey, we want to connect, and that's about it. So what's the first thing we need to send a connection using GameMaker, or really any other language? And you can note that actually network programming in GameMaker isn't really far off from using Java or any other language for networking. It's actually pretty similar. So how do we send a piece of data? Well, we need to make an envelope. So think of a mailbox or a mail system. So let's say you have a house. Your house has an address, And at your address, for some reason, you have like 1,000 or tons of mailboxes, okay? Now, you have so many mailboxes that you need to tell someone to watch for a certain mailbox to receive data, okay? Or receive mail. So you have this house with an address, and in networking terms, we can call this address the IP. That's kind of the IP that, it's basically the IP of your router on the side that your internet service provider gives you. So your internet service provider gives you an IP address, okay? And then you have like a modem or a router that basically receives data. And then you have multiple IP addresses that are called your local IP addresses. So if you have like a phone connected and a tablet connected and a computer connected, they all have their own local IP addresses. But basically, the one that you're really worried about is the one on that your ISP provides, okay? And there's a lot that goes into that. I'm not going to explain it all right now, but yeah, that's the point. Is you can think of your IP as like your house address in this mailing system. And now you have like hundreds of mailboxes. And these mailboxes you can think of as a port, okay? So now you have an address and a port. And now you need to tell somebody to listen at that port or send mail from that port. So basically, you write a piece of mail, you place it in one of these mailboxes. You need to tell someone, hey, take this mail from this mailbox and send it to another house with 1,000 mailboxes to a specific mailbox there. And they're going to have someone listening for it, okay? That's what we're going to set up right now. So kind of think of that as we move along. So, as I said, we need to set up, basically our server is going to have an IP. So let's have an address. So let's say server IP. And for now, we're going to use what we call the loop back address. And this is basically a loop back to your own computer. So it doesn't go outside of your router or outside, yeah, it doesn't go outside of your network. It's going to go to your router and basically loop back. Actually, I don't even know if it goes to your router. I think it just, your computer handles this. So that's going to be 127.0.0.1, okay? And this is your house address, okay? Actually, this is going to be the house you want to send your mail to's address, okay? So if we were actually setting this up to be online, your server would be hosted somewhere and it would have its IP address. And this is what you would give for its IP address, okay? This is where you'd put the IP address of the server you want to connect to. And again, we need to say a mailbox that we want to send mail to. So we're going to say server port. And I'm going to even these out. And this is going to actually be a number. It's not going to be a string. The IP is going to be a string and the port is going to be a real number. So I'm going to use 3113. I've had some success with this. There are different ports that you could use. So you can think of ports as maybe your computer already has ports that it's listening at for different things. So your internet browser has a port that it's listening for incoming data at. Your mail services have different ports that they're listening at. And we don't want to listen at the same ports as something else. So you need to find a port that is open. And I honestly don't have a good way of finding ports. Google, you can Google it. Hopefully this one works for you because it's worked for me on every computer I've tried. So 3113 as my port has worked. And again, this is the server port that we're trying to send data to. This is where we're going to send it. So next, we need to create a socket. Okay, and you can think of a socket as an envelope. So we need somewhere to pack our data into, and yeah, that's going to be our socket. That's going to be our envelope. And how do we create a socket? We say network creates socket, and we give it a type of socket. And you'll see once we type network in, you'll see that we have two available. We have TCP and UDP. And remember, we're going to be using UDP for this series. And there are reasons to use TCP. TCP is actually quite good for like turn-based games and stuff. But if you're doing real-time games, you want to do a shooter, top-down shooter, first-person shooter, anything like that, you're basically going to be using UDP. Okay, so now we've created our envelope to put mail into, okay? And we have the place we want to send our data. So now how do we actually send the data? Well, we're going to pack it into this socket, and we actually need to save a reference to this envelope. So let's go ahead and save a reference. We say, we'll just call it socket. That's fine. And we say socket equals network create socket. And if we look at the help by hitting F1, you actually see it returns a real, which is going to be a reference to the socket, basically. And you can see it says use the IP 127.0.0.1 to connect back to the same device the game is running on. This is what we did here. So we created a mail, basically an envelope, and on the loop, there we go, address to send to. One thing we do need to note that the envelope doesn't really do is the envelope doesn't really go anywhere, okay? The socket's always going to be available. Even after we send data, we could still write to this. We can use this socket, okay? So this, we aren't actually getting rid of the socket. It's not going somewhere like an envelope would. But the socket is kind of the box that we use to pack data into, and then the data gets sent from there, okay? And when the server receives basically our packet, it's going to actually have, that packet's going to contain our IP and our port. So it actually knows where it came from. So it can save where it came from, and it can use that in the future to send data back to us. All right, so we've created our socket. Now we need to pack data into this. And how do we do that? We have to use buffers. And if you didn't watch my buffers tutorial, go watch that. It's quite long, but it's going to tell you everything you need to know for networking, okay? Everything, I promise that. All right, so we're going to start by doing buffer create. So we need to store, let's go ahead and type it out so you see what's going on first. So we're going to use buffer create, and you'll see it takes in some parameters. Let me go ahead and maximize this and then increase the size for you guys. All right, so you'll see buffer create. It actually takes in a size of the buffer, and we're just going to use 1 byte for now. And this is going to be in bytes, and a byte is 8 bits, and a bit is a 0 or 1. So a byte looks like this. Yep, that's a byte. That's 1 byte. That's how we store data in a computer. Okay, and then we have to give it a type of buffer, and we're just going to say buffer fixed. Basically, this is saying how it should work with the size of the buffer. Using buffer fixed says we're going to tell you what size we want this buffer to be, and it's not going to change, okay? You can also use grow if you want it to kind of dynamically grow with how much data you're storing into it. But we're basically always going to use fixed because we're always going to ensure that we know what we're putting in and we know what the size of what we're putting in is. And alignment, we're just going to set to 1. This is basically after you write something, if it should skip a byte and before it starts writing again. But we're not going to skip anything. We're just going to move to the next byte every time we write something. Alrighty. Alrighty. And let's move into buffer seek. And what buffer seek is going to do, so if we create a byte or a buffer that is 2 bytes large, we need to say that we want to start writing at this first position, okay? So we're going to seek, basically it's moving a pointer to this first position. That's why we're using seek. So let's say, give it the buffer we want to seek, and we actually didn't store a reference to our buffer we just created. So we're going to do the same thing we did up here. We're just going to say send buffer equals buffer create, because this function returns an ID of a buffer. And buffer seek, we're going to give it send buffer. That's the one that we want to move the pointer on to the first position. We're going to move it, we're going to say buffer seek start. That's going to be like where we want to start seeking from. And then we're going to give it a position to seek from the start. So it moved the pointer here using buffer seek start. And then we want to give it an offset. So if you wanted to go to this position, you would put 1 here. But instead of going to this position, we're just going to stay here. So we're going to say 0. We don't want to move any more than the buffer seek start moved us to. And now we're going to write to our buffer. We're going to use buffer write. And this is where we actually put data into our basically bytes right here. Actually, it's 1 byte, so we're going to put 1 piece of data in. And we have to give it a buffer. We're going to store data in the send buffer. And what type of data are we going to store? We're going to store an unsigned 8-bit integer, also called an unsigned byte, and I'll explain that more in a moment. But also, go watch my previous videos, and I explain it in really great detail. And we give it a value. So we're going to say 0 for now, and I'll explain this in a moment. Okay, so the buffer unsigned 8-bit integer, remember a bit, this is 8 bits, and we're saying, hey, we're going to store 8 bits, and these 8 bits are going to represent an integer. And unsigned means it can't be negative. Basically, it's going to always be positive. So 8 bits, if they were all ones, you could actually have a value up to 255, and that's it. 1, 2, 3, 4, 5, 6, 7, 8. So using this, we can only have a value up to 255. If you were to use 266 right here, it would not be able to, you would get an overflow. I actually don't know how GameMaker handles this, but this is not valid. You can only have a value between 0 and 255. But we're going to use 0. And this is actually going to be a message type. And we're going to be using this message type throughout the series. And I'm going to go ahead and show you what I mean by message type. So if we're sending data to a server and it receives, basically, it's getting a stream of bits like this, how does it know how to interpret the stream of bits? Because we could have, maybe this one we're sending a connection request, right? So I'm going to say connection request. Well, what happens if we send a position update, or maybe we're spawning a bullet? How does it know how to interpret this data to spawn a bullet? Well, that's what the first byte that we store in any message that we send to the server is going to be. Is going to tell the server what the message is. And then on the server side, we could say, if the message is a connection request, we can handle it this way. And how does it know it's a connection request? It reads the first byte of the buffer and interprets it. So let's go ahead and go to this shared scripts. I'm going to create a script, and we're going to say sh for shared. And I'm going to say message types, okay? And this is just going to be an enumeration. And if you don't know about enums, you're about to learn, and they're pretty cool. So how do we specify an enum in GameMaker? We say enum, I'm going to say message type, and I'll show you why I'm putting it in shared in a moment. If you don't know what's going on, I'm about to explain it all, don't worry. And we have to give it a name of the message type. So our message type is going to be connection, connect request. Let's go ahead and say connection request. Not even going to do that, request, okay? And we're going to just say equals 0. You don't actually have to specify this in enums. It'll, by default, kind of make this 0, I believe. Did I do something wrong here? There we go. I guess you don't need a thing right there. So we're set. This is basically a constant, okay? But I'll show you why this is kind of useful to store it in an enum. So an enum you could think of as another type of object. You could think of that you made a object called message type, and you made a variable called connection request, and you set it equal to 0. It's kind of the same thing, but this takes up way less memory. It doesn't have a step event. It doesn't have a draw event. It's very efficient for just holding constants. That's all we're doing right here. We're just holding a constant. And how do we reference this from our create event? Well, instead of 0 here, since this is equal to 0, connection request is, and again, we can put other messages, so we could say position update. We could set this equal to 1, and in enum, all the values need to have separate values. All the names need to have separate values. You could actually do this, so you could have position update. And we'll just go ahead and store that too. We could change it easily later. But how we reference this is just by simply using, instead of 0, we say message type, and you'll see it shows up in our autocomplete. That's why it's really useful. You could say dot, and then I'll show you all the fields that you've created. So you just say connection request. There you go. So now you have a message type of connection request, and instead of using just a number 0, you can now use this. This tells you exactly what's going on. And you could shorten this. You could say MT, whatever worked for you. But I'm going to make it descriptive, so when you guys come back and read all this stuff, yeah, you'll know what it is. Message type, connection request. And that's what we are writing. So we're basically just writing the number 0 inside of our buffer. Okay, and now we just need to send our buffer. I'm going to go ahead and delete this. 1 byte. I'm actually going to show you what it looks like. This is all it looks like inside of our buffer right now. Yeah, that's it. Just a bunch of zeros. That's what our memory looks like, our buffer. Okay, so now let's send our data. So now we've created a socket. We know where we want to send our data. We just simply use network send, and we just send a UDP packet. You just say send UDP _ raw. Raw gets rid of, I think, an extra byte. I don't actually know what the extra byte. If you don't use raw, it sends something else. I haven't used it. I actually don't know what it does, but raw works for me, and I like using raw data. So that's what we're using. So we're going to tell it a socket to use to pack the message in, basically our envelope to place the message in. And that's our socket that we created above. And we want to give it a URL, basically an IP to send to. We're just going to send to server IP. And we're going to give it a port to send to. We're going to use server port. And we're going to give it data to send, which is this buffer we just created. It's going to be our send buffer. And we're going to give it the size of the buffer. And we could just easily use buffer get size. And we get the size of our send buffer. That's super easy. There you go. That's actually going to send a packet to our computer. That's all we need. Now, it won't currently do anything because we haven't told the server to receive it, but technically this is all UDP does. We didn't create a connection. You don't have to using UDP. You're just sending data, and if something's listening at this address we send it to, then it'll handle it. That's it. Okay. So let's actually receive this message on our server side. How do we receive it? Go to our server, SV server, and again we have our initialized. And all we have to do here is we have to create basically we have to create another socket here. Okay. Now you can think of the old envelope we created on our client side. Actually, all that stuff gets duplicated to another envelope into our server side, and that envelope is placed into its port. Okay, probably not the best description, but yeah. So we have to create another socket to tell GameMaker to listen to this certain port. Okay, so we're going to say SV socket. We're just going to call it socket because it's a local variable. We're going to say socket equals 311. Oh, sorry. Network socket. Wait, I do it wrong. Socket. Network create socket. Okay. And we're actually going to be using the ext extended. So we have network create socket, and we give it a type of socket to create. Again, this is in our server, SV server. So we give it a type, and again, we're going to be using UDP. So it's going to be listening for UDP packets. We just say network socket UDP. And we give it a port to listen at. And remember, on our client side, we're sending to port 3113. So we're going to say 3113 again. And yeah, so now it's set up to listen. We told GameMaker to listen at port 3113, so our mailbox, for UDP sockets. And when it receives UDP socket, so when our client sends it and it receives it, an event actually gets fired for GameMaker, okay? And what event is this? If we actually go to our server object, I clicked over here, and you go to add event, you can actually see we have this asynchronous event, and I'll explain what this means in a moment. And you'll see we have a networking event. This event actually gets fired when GameMaker receives a message at the port it's listening on, okay? So click it. Let's create our networking async event. Handle receiving messages. Okay. All right, so now we're handling messages. And this is actually another data structure we're going to be using called a map. Again, if you don't know what a map is, go watch my data structures video. Go Google map. You can Google map on any language and it's going to give you basically a description that you'll be able to understand, okay? You don't always, that's one thing I want to talk about. If you're trying to learn GameMaker, don't just Google GameMaker tutorial videos, okay? If you're trying to learn a specific thing about GameMaker, just Google that thing. So if you're trying to learn about lists, learn about lists in other languages. Google a Java array list tutorial. There probably will be better, more descriptive, more knowledgeable people talking about lists and these different data structures and stuff in other languages, but the concepts carry over. It's the same thing in GameMaker, okay? The syntax is different, how you use it's different, but behind the scenes, they all work the same, or similar. It's going to be the same concept. So don't always just Google GameMaker list, okay? Just Google what is a list in computer science, and it's better. You'll learn a lot more that way. All right, let's get back to it. All right, we're back to receiving messages. So again, we're receiving a map. So the reason this is an asynchronous event is if you know GameMaker, you know that it defaults to 30 frames per second. And that means the step event runs 30 times every second. That's all fine and dandy. But we don't only want to grab packets at 30 times a second. What if we had 30 users, right? So we had 30 users in our server and we could only grab a packet every step. It would take a full second to grab input from all of those users. What the asynchronous event does here on our server, we can actually grab, let's say, 10 packets between one step event, okay? So what that means is we actually need to handle, when we grab these packets, we actually need to handle what they do here. Either that or we need to store the data into some kind of list or something, and then every step we need to basically process that entire list of packets, okay? But for now, we're just going to handle the events as they come in. So again, this asynchronous event can run between steps like multiple times. So if your FPS is at 30 and your step event's running 30 times a second, you can actually receive 100 packets a second. That's totally fine. It just happens here in this event. So how do we receive the data and stuff? Well, it's pretty easy. We just use a map. So we can actually say received buffer. So this is that buffer that we sent from the client side, equals ds map. What is it? I don't usually use it like this, but I want to show you. Find value. And we're getting the value from something called async load. And this is a built-in thing, built-in map, okay? So this is the actual map that GameMaker provides us on this async. So this map is populated, it's basically filled in at the beginning of this event. And when this event is over, this map gets emptied out. It no longer is going to be functional. So we need to handle it inside this event, okay? So again, this is a map that GameMaker provides when this event fires, okay? And it provides some functions for us, or some data for us. And for example, we can get the buffer that GameMaker received using the string buffer, okay? Again, we didn't set this. This is GameMaker specified. So we're saying find the value in our async load, which is a map. And the value we're looking for is presented by the key buffer. And a map is a key value pair, okay? And that's what a map is. So there can only be unique keys. You can't have, how do I illustrate this? So for example, buffer maps to the buffer we receive, okay? And that's all a map is. I don't know how to explain it. If you didn't watch my previous video, go back and watch it. Look up maps, figure out how they work, come back. No big deal. All right. Basically, buffer, when we do this, it's going to return some type of value, which is actually going to be the buffer sent from the client. And now we need to read from that buffer, okay? How do we read? Well, first we need to move our pointer, remember? Read So we say buffer seek. We do what we did before. We have to move that pointer to go to the first byte in the buffer. And that's what we want to read. What's the buffer we're seeking? We're seeking our received buffer. We're seeking the first position. So we use buffer seek start. And we don't want to move. No offset. So now our pointer's pointing to that first byte. And let's read that first byte. We just simply do buffer read. We read the received buffer. And we now we have to give it what type we are expecting. If we go back, you'll see that we wrote a buffer U8, which is an unsigned 8-bit integer. And that's simply what we're going to read out. So we're going to say buffer U8. This is telling it, basically, when we receive this, all it is doing is receiving these 8 bits right here. This is what GameMaker has to work with. We have to tell it, hey, interpret these 8 bits as an integer, because these can actually be interpreted as a character. This could actually be a character value that could be stored in a string or whatever, okay? So this can be interpreted in a lot of different ways, but we're saying, hey, interpret it as an integer. So it's going to be the integer 0. And when buffer U8, there you go. And you'll see U16, that's basically 16 bits that are interpreted as an integer. You could store a larger number value in that. All right, so now we've read this value, and this function returns something. We have to store it in a variable. We say message type. Remember, that's what we stored. And we could do a simple check here. We could say if message type equals message type. Remember, we can use our enumeration here. Connection request. Because remember, that's all that was in this buffer that we sent was a message type. It was just this. We could say if what we read is equal to this connection request, then we can add a log message. So it says SV add log message. And let's just add a message, say new connection attempt. Okay. That's all we're going to do for now. So once we have this, that's it. And we can actually delete this buffer, clear it from memory if we want by using buffer delete. We could specify that we want to delete our received buffer. And we can actually run this now. We have to run 2 instances of it, which is kind of annoying. So I'm actually going to open another instance of GameMaker Studio 2. And we have to open this project again, basically. You can also build your program using build, create, executable. And you can open multiple instances easily that way as well. So let's say tutorial series. And now we're going to hit play on both. So I hit play on both. I'm going to minimize them now. And I'm going to move one to the left, one to the right. Now we have to create our server first of all with our left one. There you go, server initialized. And now when we click client on this right one, remember it's a different instance of the program, but when we click client, we should see a message up here saying connection attempted. Because remember, we click client. Let me actually show you because I didn't actually show you this. Oh, come on. Okay, so what happens is when the client spawns in the room, because we did all that code in the create event, right? So when we click client from the main menu, it'll actually go to the client playtest. And this is where the connection handler actually spawns. So when it gets created, it's going to call that code. So when I click client, it's going to go to the next room. The connection handler is going to get created and send a message to an address, which is going to be ourselves. And the server is going to receive that message. Check if it is of the connection attempt message type, and if so, it's going to print out a new message up here. So I'm going to hit client, and we get an error. So we have ServerIP, not sever. I missed an R in here. Connection handler.ServerIP. I'm going to abort. I'm going to close both of them out for now. All right, open up. Okay, and that was in the connection handler of our client. Not that connection handler. Oh, that's different project. There we go. Connection handler of our client. I spelled sever in here, server. What I meant. And now let's hit play on both. You actually don't have to reload again, you just hit play. I think it automatically loads the files, so that should be fine. Okay. Let's create our server and connect with our client. There you go, new connection attempt. So since this one sent a packet, this one received it. It checked if it was the correct packet type. And there you go. We have a basic way to communicate between our client and our server. And we're going to be using this message type thing at the beginning of every single message we create. So whether it's a position update, a connection request, a disconnection request, a heartbeat, a ping, a chat message send, we can have all these different message types. And that's going to be the first byte inside of any buffer that we send to the server, okay? And actually, when the server sends messages back to the client, it needs to specify a message type too, so we know how to handle the series of bits that are included in it, okay? And let me see, let me read some comments real quick. The project file doesn't have the script for add log message, or maybe I messaged it. All right, Selith, you probably messaged it. I did add it. It's right here. This is all it is. So if you want to check it out, there you go. So yeah, all it is taking in a message. It adds it to the list. It checks if the list is over a certain amount, which is max messages, which we have set at 6 right now. And if so, it's going to delete basically the oldest element in our list. That's all it does. Okay, so yeah, I think that's going to be the end of this video. I know it's not a whole lot, but hopefully if you don't understand buffers and data types, please go watch my other streams that I did previous to this, and that explains it all, everything you need to know about them to be able to do this stuff. Okay, and yeah, that's how we send data back and forth. And again, we're going to be talking about some really advanced topics coming up, so yeah, buckle up because it's going to be quite a ride. It's networking is not easy, okay? And my goal is to make it as easy as possible. And again, I'm not trying to give you, one second. I'm not trying to give you all the answers to how to set up a great framework. I'm not telling you, I'm not guiding you through a project that you're going to just be able to build your game on top of necessarily, okay? I'm giving you all the knowledge that you need to know to be able to implement your own networking system. Or if you want, you can use a framework like GMNet, which is a pretty cool framework, as I mentioned earlier in the video. GMNet is kind of a cool project. You just basically give it object. You say, hey, I want to sync this object across the network. I want to sync these variables across the network so they stay in sync with the client, or the server and the client, other clients. But it's not perfect. It's missing quite a bit as well. It's really hard to make a framework that covers everything your game needs. That's why there really aren't a whole lot. Basically, if you want to make a game, you need to start with this stuff and you need to implement it how your game needs it, okay? So all I can give you is the knowledge, and there's not a whole lot out there about how to do this stuff. There's theory behind it, but actually implementing this stuff is a whole nother story. And yeah, I'm showing you how to implement this stuff. So we're going to go through basically I'm taking you through the process I went through to learn this stuff, which isn't going to be perfect, but you need to see the problems that certain tools and certain things are solving to be able to understand them. So we're going to run into those problems and then we're going to fix the problems, okay? Because there are a lot that come with this as we go. This is actually going to be kind of a top-down movement system. We're going to be doing just basic movement and client interpolation. So when we first implement it, the other clients that we were watching are going to be kind of jittery. They're going to appear jittery on our screen, okay? And that's totally normal. That's how every game starts out. And then we're going to smooth it out using specific code that we're going to create. How other games do it, that's how engines do it, okay? Because we can't feasibly send 60 packets a second to keep our frame rate up at 60. Basically, we can't have the other clients appear like they're moving smoothly at 60 frames a second because we don't want to receive 60 frames from every client every second. So if we had 100 clients, we'd have to receive 6,000 packets and process those every second. That's just a lot of work, okay? So it's more realistic to grab a snapshot maybe 10 times from each client, okay? And then we can make the changes based on that, right? So that's more realistic, but that makes our clients look like they're moving at only 10 FPS across our screen. So we're going to use something called interpolation. Basically, we're going to smooth out those movements. We're going to fill in those gaps between the 10 frames a second. And yeah, so that's one thing we're going to fix, and there's going to be a lot of other issues, I promise. Pause for a second to write out script, but I got the theory behind the buffers, sending messages, receiving, updating, and whatnot. I'm still stuck at a point where I can only get working locally. All right, so we're going to go over that stuff in the future. We're going to get there. So you can use UDP hole punching, but that's not really the way to do it. You're going to have to do port forwarding, and I'll show you how to do that. I'm not going to show you right now because it takes a little bit of work, and everyone's computer is going to be a bit different. But basically, I can kind of explain the reason it happens. Maybe I can think of it off the top of my head. Basically, what happens is, let me illustrate it. Paints. You have a server here. Let me see. Or not a server, you have a router here, okay? It's got like an antenna thing. And it has an input here. And then it has its outputs basically here, okay? So maybe this it splits off to 4 different outputs. Now, your input has a specific IP that's assigned by your internet service provider, okay? And the reason is because we use IPv4, which is basically a 32-bit address. So if you followed the buffers and stuff, you know that basically one byte can only store up to the value 255. So in an IPv4 address, you can only have a value up to 255, 255, 255. Oh, crap. Sorry. I wasn't putting it on the screen. Okay, so yeah, you have your router, and you have, your router has an input. Here, let me annotate this. From service provider. This is provided by your service provider. And let me cut this out. Let me increase the size here a little bit. Okay, so an IPv4 address, here, I'll write this out, PV4 is a 32-bit address. And if you know 32 bits, that equals 8 bytes, right? And this is what we now have IPv6, which is a different storage, but mainly the mainstream is still IPv4. The reason we have IPv6 as well is because we're running out of basically addresses. So every IP address on the internet is unique, okay? It has to be unique. It has to be a unique address. So we have 8 bytes to work with. And if you remember 8 bytes, we can only store a value up to 255. So the maximum IP address we can have is this. So we can have this, we can have 0 here, we can have a 1 here. This is all that we have to work with, is zeros in all these spaces to 255 in all these spaces, which I think is about 4 billion unique. I think you can have like 4 billion unique numbers using this. But again, we're running out. There's a lot of devices. And the reason you only have one address from your service provider is because it gives you a unique IPv4 address, okay? Now, that's coming from this side. So it comes from this side, right? So you have this unique address coming this way. And then it gets in your network, and you'll notice your devices have different IP addresses. And this is because your devices have local IP addresses, okay? So they are not really connected to the web. Anything that goes out basically runs through this address, okay? It doesn't run through whatever address it's assigned. So let's say this is your iPhone, okay? Right here. Let's say it has an IP address. Well, or a computer, whatever. I don't even know. But this has a different IP address. It's like 192. Whatever. So, and then you have another computer connected to your network, okay? And it also has a unique address. Boom. So you have another unique address here. Whatever. So there, you can have all these different local addresses because they are not accessible from the World Wide Web, basically. But this address is. So when your router or your modem receives a message to this address, it now has to route to a certain device, okay? So then it sends it to one of its local IP addresses, okay? So you have the splitter, it sends it to a local IP address, basically, and the issue comes from, we can run it locally because we can send using a loopback address to this, but if we go outside of the network and come back, we have to mess with, basically, these different ports and stuff when it comes back into the network. So our router or whatever that we have here, modem router, needs to basically know the address that we want to send it to, which needs to be set up somehow. And it also needs to know the port to send it to on that address, or basically it's port here. Basically the port comes from here. So this comes to where we do port forwarding. So when we have to actually go into our router settings or go into our settings and go into our IP, and we need to say, hey, when we receive this message, basically for this port, we need to route it to a specific local IP address, and it needs to go to a specific port at that local IP address. So then on your computer, so basically this is the IP that a client would connect to, okay? This 192 blah, 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 okay? And I believe I have that right. I think I have that right. And when it receives it, then it determines, given maybe a port or whatever, how it's set up for forwarding, where it needs to send the message to locally. And that's the reason that you can't just directly set up, you can't have people just connect to you directly over the internet, okay? You have to set up port forwarding usually. And again, there's stuff like UDP hole punching that's hard to do in GameMaker. You actually have to have like a Java project set up or something in another language set up for that feature. But usually you just do port forwarding because you want to have a server running somewhere and you don't need to ever really change the ports that it's running on. You just set up, hey, my server is going to be set up for these ports at this address. So you set up your port forwarding and you just have your server running. And now your clients can connect to that server, okay? And there's also, that comes with some issues too. There's actually, like if you use PlayStation or Xbox, they actually use like the PlayStation Network, which is kind of an intermediate service that kind of helps clients connect to each other because of, once again, the issue that you come up to with this thing. There's actually an issue when two routers try to connect directly to each other. There's no way, because basically when this address goes through this side, this address flip-flops, basically replaces this address before it sends the data. Basically, so this is your, let's say this is your computer. Send a packet. Before it leaves your router, this address, let's say, remember you have your socket. On your socket, this address gets changed to this address, and then it leaves. So now the guy you're trying to connect to doesn't even know exactly where it's trying to send. It doesn't know it's trying to send it here. It just knows it's trying to send it here. So when it sends data back to here, it doesn't actually know, your router doesn't know where data needs to go, right? So that's when an intermediate, like a PlayStation networking service comes in, okay? So you send data, it basically, this sends a request to this intermediate area, and this guy helps, basically it'd be like the PlayStation Network, helps two clients recognize each other, basically flip-flop the IP and everything back. Basically, give it the address, and it's kind of a weird workflow. It actually goes back into this and then back out again. It's kind of odd how it works, but yeah. I know it's a bit confusing. There's actually, I'm reading a book about it, all of this stuff. I'm reading a book. If you want a really good networking book, guys, I'll link it. Networking. It's actually really useful information, even if you're not planning on making a networking game. Networking game. Where are you at? I'm gonna find it. Your order. Hey, break. There we go. Right here. Let's make sure I'm not showing like any account information or something. Okay. So this book, Multiplayer Game Programming, Architecting Networked Games. You can get the Kindle edition. Read it right now, $31. Really good book. Has tons of information on how to solve a lot of issues that come with multiplayer game programming. And if you don't want to read that, that's fine. Just follow this series. I'm basically going over everything that this book talks about. So you can follow along. But yeah, multiplayer game programming, architecting networked games. Really useful information. It's a really good book. There's not really a whole lot out there for multiplayer programming. There's just not. There's a lot of theory that you can read, but implementation and in-depth stuff, yeah, there's just not a whole lot. Yeah, so let's just look up port forwarding. That's all you need to do to get it someone else to connect to you. Is you need to make sure that your router knows where to send data to. So you need to forward ports on your router, basically. So you need to open up your router settings. So you log in your router or whatever. And let me look at mine. What is the routers dot 168.1.1? 192.168.0.1. I'm trying to remember the router IP. Hold on. Up in a second. 92.168. Where is it? Does anyone know the router IP? The 168. Crap, I don't remember. Let's see. What router do I have? Link sys router IP. There it is. 192.168.1.1. Hold on, make sure this doesn't shoot up any information about my stuff. Depends what router you have on how you have to set up port forwarding and stuff. You might have to set up your computer, some settings too. Oh wait, is this showing my stuff? I didn't even look. That's not my password. Oh, that's the guest. I was like, hold on. Let's see. But yeah, you'll see some stuff here. This isn't, I don't believe these are the settings that you need to use, but you'll see I have like advanced routing. You might have to do something here. I haven't actually done port forwarding on this router. Hold on. Yeah, the settings are usually in there for port forwarding and stuff. I think you could do it through Windows as well. But yeah, I'll get there. I promise I'll get there. If you follow this series, we'll get there because I know a lot of people have that same question. So we will get there. Modem. Yeah, I don't think I can connect directly to the modem. this. But yeah, we will get there. Don't worry. It's gonna be a ways. That's probably one of the easier parts of it. I mean, if you really have everything else down, then currently a few minutes away from getting it to work online. The hard stuff really is setting up the architecture of your program to be able, for you to easily be able to kind of work with stuff. So as I said before, after we go through the series, you're gonna really be able to understand like GMNet engine. So like GMNet engine is a networking engine. Again, it's not perfect. If you're probably gonna have to create your own stuff in it, even if you are working. Basically, even if you use this stuff, to make a really good game, you're probably gonna have to implement your own networking stuff on top of it. But it does have a lot of base stuff. So basically, you give it an object to sync. You give it some variables to sync. So like the POS here is actually just syncing the X and Y values of this object. You give it how often to update those values. So it's a pretty cool library if you want to just jump in and get started. But again, if you're trying to make a real-time game, this is going to be difficult. Follow along with this series, and it's going to clear a lot of this up that you'll have to do here as well. So even using this, you're going to have to still use concepts like client-side prediction. You're going to have to use concepts of interpolation, client interpolation, server reconciliation. You're going to have to use all those things. Anyway, the only thing that this really does for you, well, it does a lot for you, but behind the scenes is writing the buffers and handling the messages. Makes it a bit more streamlined, but you can actually create your own libraries for that as well. Like, there's some pretty cool libraries out there. There's a JavaScript library, game engine, JavaScript network, game engine? Not game engine, I guess it wouldn't be. Network engine. Where's it at? Script. Multiplayer. Wait, it'd just be a server, I think. Game server? Sorry, I just looked at this not too long ago. Not any of those. Wow, why can't I find this one? Actually, it's a game maker. Another game maker thing. I forgot. It's a game maker. Another game maker thing. Patchwire. There it is. So Patchwire is actually a server run in JavaScript, and it's not. It'll work well for some things, but it's not really for. You're not gonna be able to do real-time stuff very well with it. Basically, it's sending messages and receiving it, and you're gonna have to know how to do some JavaScript as well. So yeah, it's kind of complicated, but it's kind of cool how it works. Basically, yeah, you send this, you give it a user. Oh, this is receiving. So you actually serialize some data like this in JSON, and it receives the JSON, and it does some stuff with it, and you can broadcast it to all the other clients. It's kind of cool. Really lightweight. It's kind of neat. But yeah, you're gonna have to understand some pretty low level stuff. So that's why I'm doing this tutorial. After we go through the tutorial, this stuff's gonna be easy peasy. You'll be able to work on top of it. You'll be able to make a full 3D, or not 3D, full multiplayer game. Even if you wanted to get into 3D, all the concepts are gonna apply as well. I'm just rambling on now, but yeah. Let me read your comments. Yeah, you can have your, using raw, you can have your server and anything. I'm writing a Java framework right now for GameMaker. But as I said, it's quite hard to, it's hard to make a framework that's good for everything. Like I said, if you're developing a game, you have to write your own stuff. It's really hard just to use a framework. It's just hard to make a framework that does everything, I guess. Yeah, Silith, your server is just sending packets, but again, popular, or not popular, how most real-time games are done, the server actually does all of the logic. The client actually doesn't do logic. So in the days of Doom, the game Doom, let me go ahead and get my face on here. So in the game of Doom, when they implemented like local networking and stuff like that, actually that might have been, that wasn't server hosted. I guess the early days of Quake would be kind of a game I can think of now. The server actually did all of the logic, and the server still does all of the logic, okay? So your server actually simulates your game, which makes it hard to use GameMaker and Java in, okay? Because let's say you made a game in Java, or sorry, in GameMaker. You would have to write all of the logic of the game in Java as well, okay? So what we're going to be doing in this series, and kind of the mainstream way of developing multiplayer, is having your client. Oh, wow, that's a cool brush for paint. Never knew it had like a paintbrush. You have your client, and you press your right arrow key. Okay. Let me get off of it though. It's a cool brush, but so you press your right arrow key. This is actually a request that goes to the server. Okay. And the server actually processes this request and simulates it on its own area, okay? So the server actually simulates this movement happening. Now, if this movement's valid, if you're not bumping into a wall or whatever, it sends the client back its updated position, okay? And it sends all the other clients the updated position, okay? So your server is actually doing all of the logic of your game, and it has the final say of where the client ends up. What this does is it keeps all the clients in sync pretty well with each other, and it also helps prevent cheating, because now your clients can't just warp to the other side, because if it tries to, your server could say, hey, that's invalid. That's an invalid movement, and your client will just get moved back, okay? Or that update won't actually get sent to the other clients. Oh, I am doing it on screen. I'm bad at this. Let me redo this. Okay, let me set this up better. Anyway, okay. So, I guess I'm going to explain this in the next video, but you have a client. Let me up the size. Up it to 40. Save your client, and you have a server. Your client, want it bigger size. So you press the right key, okay? Your right arrow button to move. Client sends the server a request. The server processes this request. It has a simulation right here. So your player's here. And this is actually client 1, okay? This says client 1. The server tries to move client 1 to the right, okay? And if it successfully moves client 1 to the right, it sends the data back to the client that it was a successful move. And the server also sends the data to all the other clients at the same time, okay? So it basically updates all the clients with this client's new position. And the server is receiving this same input request from all the different clients, right? And anytime a movement is valid, it sends it to all the other clients, okay? So your client is actually not doing any processing on movements. So your server is actually simulating your game, which makes it hard to make a server in Java when your game is written in GameMaker, right? Because you can, I mean, if you have the same collision detection algorithms and everything in Java, then technically you could send your map file to a Java server and it could recreate the game world. But basically it needs to do the processing, okay? So your server actually does the computations for the movement and updates all the other clients. Now, this comes with a ton of problems, okay? Number one, if you're pressing the right button, the right key on your keyboard here, then you're having to wait to get that reply back before your character actually moves on your screen, on your client. This is you right here. You. So you hit your right button. You have to wait for the server to process it and send it back to you before you actually see your character move on screen. This is kind of irritating. It's pretty laggy, right? It is laggy. Even if you're doing it locally, it feels kind of wonky. And how this is kind of prevented is using client-side prediction. It's a technique that basically you do the same processing as the server is going to do, okay? So you actually try to move your player using the same algorithm or same movement script that the server is going to use. And you move it instantly. Now, when you get that reply from the server, you compare your new position with the position the server sent. Now, this can get out of sync as well, but what happens is, since you're doing prediction on your side of what you think the server is going to output to you, you see yourself move instantaneously and you don't feel that lag, okay? Now, when the server and the client disagree with each other, then you have to do something called server reconciliation. Which I think that's awful. I don't know. I think this is the hardest part of the entire thing. Basically, you have to figure out how to reconcile the difference between the server and the client if they become out of sync. And there's a lot of ways to do this, and we're going to go over it. I'm not going to explain it all. Basically, your client saves its previous positions for maybe half a second. And if your server and your client disagree on a position, then you kind of go back in time. So if you play a first-person shooter and you ever experience yourself warp, like you walk through a doorway, and you experience yourself go backwards, all of a sudden you're warped back through the door, that's because you and the server disagreed. There was probably a packet loss. So some of your packets didn't arrive to the server, so the server never received your new input requests. So when the server sent you your updated position, it wasn't where your client expected it to be, so it moved you back to the last place. Basically, the server remembers you being. And yeah, that's how real-time multiplayer is set up, and that's the stuff we're going to go over. So as you can see, server actually does a lot more than just process or send clients data. It actually does a simulation on its side, which is, yeah, kind of complicated, but it's actually kind of cool. So your server basically runs at, let's say, 30 ticks, okay? So it processes its asynchronous events as many times as it gets packets, and it's updating players' positions on its simulation. And maybe 30 times a second, it sends position updates for all the clients. So the updates could actually happen 100 times a second, right? But only those 30 times a second, it's actually sending packets out to the clients. And that's where, on your client side, it could look choppy, like the characters moving at 30 frames a second because you're only receiving updates on their positions that many times. So you're getting this choppiness. But then you do interpolation. There's a few ways to do it. The easiest way is just to use a lerp. Basically, you have the client's current position and their new target position, and you lerp between them using some value. Usually it's the expected latency, so you keep track of how long on average it's taking to receive updates. You can kind of use that to determine what value to lerp by. So this is just basically lerping between these values, and it's making the characters appear to move smoothly. So even though you're only receiving 30 updates a second, it's appearing to move 60 times a second, as fast as your step events are running on your client. So it's appearing to move smooth because you're filling in those gaps between updates with interpolation. So that's one way of kind of interpolating. And yeah, there's a lot of techniques like that that come in. So that's the kind of stuff we're going to be going over, and that's what I'm going to try to do. So it's really complicated stuff. We started simple today. Some basic sending a packet, but you know, that's what it starts out as. You guys have any questions? Oh yeah, and to answer the original question, that's why having a Java server, a C++ server is kind of difficult. Now, if you wrote your game in Java, it's easy to build a server because you already have the logic created in Java to use for the server prediction. But when you have a game built in GML or GameMaker, to build the simulation in Java, you're going to have to simulate how GameMaker does its collision checks and stuff like that. So it makes it a little bit more difficult. Yeah, you can actually use multiple ports for different messages if you wanted. So you could actually, in GameMaker, right now, I'm not going to do it necessarily right now, but let me. You could actually set up a, let's say you had a messaging port equals 6116, you say. You could actually set up a message socket equals network create socket network socket TCP. So you can actually have a TCP connection going on. So what I originally did was actually have a TCP that managed my connection. So when this TCP, because it always ensures connection, right? When this TCP connection was lost, then I would disconnect the client. So I would actually have a port for TCP and UDP at the same time. And I just used TCP for handling connection, but it became kind of convoluted and not really good for tutorial sake because you're messing with two different ports. It's kind of confusing. And yeah, and you can implement TCP behavior with UDP. But to answer your question, yes, you can have multiple ports that kind of have different functions if you wanted. So yeah, that's kind of cool. Cool thing to do. Yeah, you could do that. I'm trying to think of a good example to use it on, but it's definitely possible. You could have multiple ports. You could even have another UDP socket to listen on, and you could handle, maybe they handle different types of data. Totally possible. Or maybe you're running multiple servers on one machine. Since you have the same IP address because you're on one machine, you could have just multiple ports for different, basically, games that are happening. So you could have like 10 games on your computer going at once. Your server's hosting 10 games, 10 different ports that you use. As far as Java and Node.js, you're a very good Java developer. You know what you're doing. You can outperform Node.js. Node.js, though, handles things like multi-threading for you. But if you know how to do multi-threading and stuff, then Java is probably the way to go. What I mean by multi-threading is you have your main thread that your game runs on. So, for example, GameMaker is basically single-threaded besides these asynchronous events. Those are probably handled on different threads. But if you, for example, created a while true loop, your game would completely freeze here, right? You could do nothing else in your game. That's because this is blocking your thread, basically. So you have your one thread that your game's running on, and it's this while loop, and your thread's now stuck on this. Nothing else is happening in your game. Now, when you're writing a server in something like Java, you have this while loop happening because you have to constantly be listening to a port, right? Receiving data. And now you have to not only receive this data, but you need to process the data when it's received. Now, if you just process the data right when it's received, what if the data takes a while to process? While you're processing this data, you're not actually receiving any more packets. So you're missing packets that are being filled into your inbox, right? So what you have to do in Java is create a new thread. So you have this while loop that is constantly listening. Now when this while loop finds a message, it'll add a message to like a list, okay? Like a data structure. So this list would be like up here. A list of packets, of received packets. Now in Java, you can multi-thread. It's very nice. Java has really good multi-threading. So you create a second thread to basically another while loop would be happening somewhere on a different thread on your CPU. And on this thread, so this one's always listening. When it receives a message, all it does is add the message to a list of packets. And a separate thread is waiting for waiting for packets to arrive in the list. So when a packet gets added to this list, this loop will then process that packet. So this one just listens, adds the packet. This one's always processing packets. So there's things like this where you have to listen, you have to process packets. If you have different types of packets like a database calls take a while because you have to wait for a reply with database information. So you want that to be on a separate thread as well because you don't want that to slow down your position updates and stuff like that. So you have multi-threading. Now a node handles basically most of this for you. You don't have to do any of this multi-threading stuff. It basically is really easy to set up the server, really easy to process it, and it's quite fast. So yeah, it's a good thing to use for servers. Works really well. Okay, Silith, so you asked about the host client. I'm trying to think, Call of Duty. I want to say that Call of Duty is actually server hosted. Oh no, they are client hosted, huh? Once you leave. You know what? I don't know the exact answer to that. I'm pretty sure that. I'm trying to remember. So I'm pretty sure that those are done on dedicated servers as well, but maybe they aren't. Maybe it is client host or yeah, client hosted. But in that case, you're just getting rid of the middleman, the server, right? If you were doing it basically peer-to-peer, so your computer is hosting the game, your computer is a server basically. That increases the ability to cheat though, okay? So that it's not a bad way to do it, especially if you're doing a Game Maker game, I guess, but yeah, it's a different story. I haven't actually messed with that, so I don't have a good answer for it. Okay, what of the ability to have a web host? Safe to assume it would be find host willing to host JavaScript. No, not necessarily. I mean, if someone's hosting your server, all they have to do is pop open your Game Maker project, and yeah, I mean, that's technically it. There might be a little bit of setup for port forwarding and stuff, but it depends on the it depends because like if they're using Linux-based stuff, yeah, JavaScript gets hosted really easily on like really easy to set up for Linux and whatnot. So I'm not positive on that, but honestly, if I made a Game Maker game, which I have plans to work on I'm working on a zombie survival online shooter, survival type thing. It's kind of a co-op. I'm probably going to build a server at my house and just host it here. I mean, because the thing is I'm not gonna have very many players at once. The way I'm sending messages is pretty optimal. It's less than 100 bytes a second, so it's not really a whole lot. And as far as processing goes, it's not a whole lot either, because I'm only gonna have, it's co-op, so it's gonna be 4 to 8 players at a time maximum in a game. Now, if the game got bigger and there were hundreds of people playing, then I'd probably have to look at outside hosting. But in a lot of ways, you could probably just host it from your home just fine if you have a decent internet and you live in a decent area, because your latency is going to increase if you live far away from your users. Oh, okay. Yeah, I don't actually know about the different services. I think Amazon does some hosting with their AWS stuff. I'm not actually positive in the pipeline of it, guys. I haven't actually went up there. Like, I've always done all my own hosting on my own computers, because I've never had a game that required me to have to go outside of it. So I think some engines actually have their own hosting and stuff. I know Amazon has their own game engine, and if you do anything networking, it gets hosted through their own basically web services. Yeah, and I don't know, Google Cloud might. I'm not positive. I really don't know. I'll have to do more research into that. Oh, that's pretty cool. Yeah, check that out then. DigitalOcean is really nice for hosting stuff. That's pretty cool. So you just set up a VM like on your own machine and send them the VM, or you just have access to the VM remotely? Probably access remotely, right? That'd be kind of cool. So yeah, that makes sense. Like, that's what we do at work a lot, is have VMs. So you don't. Yeah, so basically, like, on some server somewhere, they'll run a virtual machine, but you have access to the virtual machine. Obviously, they aren't going to give you access to like their actual computer that they're using for hosting, but yeah, it could be set up as a VM, and you could have access to that VM and basically do what you want with the virtual machine and hosting it with their processing power and whatnot. So yeah, you could have like remote access to the virtual machine and set up your program. You connect to it via a remote desktop or whatever, depending on what the operating system is. Yeah, I'll definitely keep this. I really like this networking stuff. I've been into it a lot the past couple months. I've been basically exclusively doing networking. So yeah, it's pretty cool. Pretty fun, because I really like optimization of stuff, and yeah, as you can see, I have these buffers, and this is about as low levels you can get working with different bits and stuff. So at least with Game Maker. So yeah, it's pretty fun. I'm probably gonna stop it at the 2-hour mark, guys. I think when people see the 2-hour length on this video, they'll probably not even watch it. I might have to later on come back and do videos on these, but I've recorded this one like 3 times, and I just haven't had the time to. It's really difficult for me to record something, leave it alone, and then come back and edit it and stuff, because when I come back, I just feel like I could record it better. So then I just re-record it, and then I don't have time to edit. Then I leave it alone, and then I come back again. I'm like, I'm just going to re-record it again. So I end up re-recording these 40-minute videos multiple times and never actually edit them. So yeah. I'm gonna try to do the live streams, and I should have more time coming up. I'm gonna be moving into a house. On the 15th, I'm supposed to start moving in, so hopefully I'll have an office there. So hopefully I'll be able to get some more videos out, get some more time to edit and whatnot. My buffer is 1 byte large. Yeah, 1 byte. But it's bit level. Like I have control over what bits are getting set inside of memory, which is what I mean. Diffman ROM. Yeah, I know Coding Train. I've watched a lot. He's really good. Really, really good. Fun to watch. I had some people just join in. If you guys missed it, don't worry. I've actually been kind of rambling for the past 45 minutes. So the video, the actual tutorial's not this long. Please go back and watch the video. It's going to upload probably about 20 minutes after I end this. It'll be uploaded. Probably starts at about 5 minutes, and the actual content is probably about 30 minutes long, 45 minutes long. And it'll show you how to basically set up a client server and get a buffer going. This is going to be the start of basically our networking, and by the end of it, you'll be able to basically should be able to create a game. And at least if you can't create a game, you'll know how to understand stuff when you look up tutorials or look up articles on different methods of doing things. You'll understand how to implement it. Yeah, he's really good. I really like watching Coding Train. He has a lot of cool stuff. So like if you, yeah, I'll show you like some of I think his most useful stuff. He has some really good stuff that's really relevant. It's kind of hard to implement with GameMaker because he uses like things like vectors and stuff, which we kind of have to interpret using length dir. The length dir function makes it kind of hard to translate it, but if you get it, it's pretty cool. So some of his really cool videos are definitely neural networks. If you've never messed with neural nets, they're awesome. It's really interesting stuff. But where are you at? Here's this stuff. Additional topics. Working with data. I don't know. But by the way, watch. Yeah, you guys all should definitely go here and watch this. Download processing. Processing is a really cool. It's a JavaScript based thing. Where's it? No, that's not it. Processing programming. Processing.org. Here you go. Go here. He's basically on the front of all
a couple
this.
Things. What are all the functions of things, and for larger, more.
Come here and watch this. Basically, it's a setup for you to start like programming in like a visual way.
Incrementation level.
So
look how that drastically affects.
Kind of shows
you.
Used
to be built will sort of turn on.
But basically, you're programming in basically Java or JavaScript-ish syntax, and yeah, he does all of his tutorials through this. So like, he has processing tutorials down here, whatever. And then, oh, this is it. He does all these simulations with this and all these tutorials, which is cool. So like, you can go here and find a good one. Introduction to Physics Engines. So he has 28 videos on this topic. So he goes through in depth. He does the math, everything, guys. Like, it's not just programming. He goes through
raw egg test.
Hello, welcome to the first video in a playlist about physics engines.
Yeah.
Now, strangely enough,
he'll show you how to implement these physics engines and stuff. He has all these different topics he goes over. He does the math and everything. Yeah, he's awesome. You guys should definitely check him out. Yeah, he has video on LERP. I love the natural systems, especially the autonomous agents. So you can, where's the one that I really liked? Where are you at? group steering behavior. So like this is like an AI type thing. So you want to get like this effect. I actually implemented this in GameMaker as well off this tutorial. It's all math. So you can see they wait for each other. They kind of slow down when there's a big group and they're all getting through this little pathway. And it's basically just group steering behaviors, how to make things steer when in a group. And you can see their speeds decreasing as they come up on the group, and yeah, they're kind of accelerating through there. It tells you the math behind it and shows you how to implement it, and yeah, it's pretty cool. And you can follow along with processing the program. It's really lightweight, just basically a script, and there you go. Kind of just pump out the stuff. Pretty cool. Definitely check them out. But yeah, I'm going to go ahead and get off here, guys. It's been 2 hours. Thank you guys for hanging out. Again, if you didn't get to watch the video, download the project below. I'm going to try to get this stuff started on Git so I can have the different versions. I'll try to do that tomorrow. And I'll update the description down here. And yeah, you can follow along with this, though, if you just download the project in the description. It starts at about 5 minutes into the video, and it's not 2 hours long. It's about an hour long. The actual tutorial is probably about 30 minutes, 45 minutes. And it'll show you how to basically set up your server, set up a client, get a packet sent, receive a packet, kind of set up for our future videos. So thank you guys for watching, and I might stick around on the chat for a minute, but I'm going to go ahead and jump off here. So I'll see you guys next time.